Welcome to this lesson on neutralization. Neutralization is one of the most important chemical reactions involving acids and bases. In this video, we'll explore what happens when an acid meets a base and why this reaction is so significant in chemistry and everyday life. Neutralization is a chemical reaction where an acid and a base react together to form salt and water. When these two opposing substances combine, they neutralize each other's properties. The acidic nature of the acid and the basic nature of the base cancel out, producing new substances that are neither strongly acidic nor strongly basic. The general equation for any neutralization reaction follows a simple pattern. Acid plus base produces salt plus water. This is the fundamental formula that applies to all neutralization reactions, regardless of which specific acid or base you're using. Remember this equation, as it's the foundation for understanding how acids and bases interact. Let's look at a concrete example. When hydrochloric acid reacts with sodium hydroxide, they produce sodium chloride and water. Hydrochloric acid plus sodium hydroxide yields sodium chloride plus H₂O. The sodium chloride produced is actually common table salt, the same salt we use in cooking. This shows how neutralization reactions can create familiar everyday substances. At the ionic level, neutralization becomes even clearer. The essence of the reaction is this: hydrogen ions from the acid combine with hydroxide ions from the base to form water. H+ combines with OH- to produce H₂O. This is the core reaction happening at the molecular level. The remaining ions form the salt, but the key process is this combination of hydrogen and hydroxide ions creating water molecules. Neutralization reactions have four key characteristics. First, they are exothermic, meaning heat is released during the reaction. You can often feel the container getting warm. Second, the pH changes as the solution moves toward pH 7, which is neutral. Third, salt formation occurs as an ionic compound is produced from the reaction. And fourth, water production always happens, as H₂O is always formed as a product in neutralization reactions. Let's explore more examples to strengthen our understanding. Sulfuric acid plus sodium hydroxide produces sodium sulfate plus water. Notice that 2 molecules of sodium hydroxide are needed to neutralize 1 molecule of sulfuric acid. Nitric acid plus potassium hydroxide yields potassium nitrate plus water. And acetic acid, which is found in vinegar, plus sodium hydroxide produces sodium acetate plus water. Each reaction follows the same pattern. Acid plus base gives salt plus water. Neutralization reactions are incredibly useful in real life. In medicine, antacids neutralize excess stomach acid to relieve heartburn and indigestion. In agriculture, farmers add lime to neutralize acidic soil, making it suitable for growing crops. In first aid, neutralization helps treat bee stings and ant bites by countering the acidic or basic venom. And in industry, neutralization is essential for wastewater treatment and pH control in manufacturing processes. Understanding neutralization helps us see chemistry in action all around us.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.